If you want to learn how to gain insights you can act on and solve business problems with data, all while building a data-driven culture at your organization, sign up for Pragmatic Institute's new course, Data Science for Business Leaders. Find out more at pragmaticinstitute.com/data.
Welcome to our Ask Us Anything with the founder of the Data Incubator, Michael Li. Michael, we're so happy to have you. Welcome.
Hey, great. Thank you so much for having me.
Yeah, absolutely. Really excited to sort of dig into some of these questions today that got asked for you specifically, actually. So they are ranging from everything from curiosity about the fellowship itself to sort of those more in-depth questions just about data science and some of those like really exciting opportunities that can come from completing the TDI program. So while you need no introduction to us, for the folks that are listening live on the call, did you maybe want to start by giving a brief introduction, Michael, and saying hello?
Yeah, sure. So I'm Michael. I'm the founder of the Data Incubator. As you guys probably know, it's an 8-week fellowship to help people with masters and PhDs make that transition from kind of an academic or a non-data science industry career into a career in data science in industry. And we've worked with probably thousands of fellows at this point to help them make that transition. And it's very exciting. We do this 4 times a year. And my understanding is that the application is actually going to be closing soon for the summer session, which is actually tends to be the most popular one because a lot of people get the summer off. So that's going to be very exciting to see our latest cohort. So my own background is I quant and a data scientist. So I used to be a quant at a lot of the kind of big banks in Wall Street. JP Morgan, Chase, some of the hedge funds like D.E. Shaw, made that transition over to data science, where I was the first data scientist in residence at Andreessen Horowitz, and then eventually moved over to Foursquare, where I ran data science monetization before starting the Data Incubator.
Well, I love it. I'm so excited that we get to have the source today. So we are delighted to have you with us. I know we already have a ton of questions that were submitted, so I want to pop through as many as possible, Michael. Again, I think the best thing to maybe do is maybe just open it up now that we kind of know how things got started, maybe some questions about maybe why you decided to start the Data Incubator and, some of the reasons why you kind of move forward with that program.
Yeah, so so as a person who sort of felt the pain points acutely on both sides of the interviewing table, so to speak. So both as a PhD from Princeton trying to enter industry, and then on the flip side of that, being a hiring manager, now trying to hire people into data science, I felt like I saw a lot of the shortcomings of the existing process, and I wanted to sort of think of ways to help make that less hard for both sides. And so that sort of was the genesis of the fellowship and how we started with this fellowship that helps people make that transition in their careers and helps hiring companies hire top talent.
Yeah, it's really fantastic. I mean, I've gotten to see some of the impressive success stories. And, I think that the people that are hiring the TDIs are, that's just so they're getting more and more impressive. So it's a really exciting time. I definitely wanted to ask you sort of as we kind of know a little bit more about the program, what are sort of some of the entry standards, right, for acceptance here at TDI? What should people really know before they put in those applications?
Oh, yeah, that's a great question. I think we're looking for people who are really excited about a career in data. One of the things we ask you to do is sort of to take a data set that you have that is publicly available and start playing with it a little bit so that you can start get a sense of sort of what it's like to play with data, to work with data, to see if this is a good career that makes sense for you. But then also we want to sort of see if like you have that kind of intuition about what to do with data and sort of some of the insights into what you can do with data. And it doesn't mean you have to be a fully formed data scientist on day one. We're obviously not expecting that, but we do want people who demonstrate a certain inclination for it. And if you think about data science, it's in many ways sort of this intersection between programming, math, and narrative and storytelling, right? And so we're looking for people who can sort of demonstrate the fundamentals of those skills or sort of the basics of those skills. And so if you wanted to sort of prepare, this is often the question we get, right? How do I prepare for the application? How do I prepare for the fellowship? We sort of say like, hey, look, really focus on those three core skills, right? Start brushing up on some programming, make sure you sort of get caught up a little bit on math and stats, and make sure you can sort of think about, especially for your project, how do you tell, or your proposed project, how do you sort of find an interesting data set and then tell a sort of interesting story around that that's compelling and sort of thesis driven and that some business partner might find interesting.
Mm-hmm, mm-hmm. And, we get another question as well all the time, right? So a lot of people know that we have our fellows, we have our scholars, but they're not quite sure what the difference is between the two. Can you kind of talk a little bit about that?
Yeah, so that's right. So we started with the fellowship, with just the fellowship, and it's a free program, free for 8 weeks, and we get all these applicants. We take the top 2%. It's a very selective program, and then we work with them. We train them up, and we help hiring companies sort of get hire from the program, and they get a recruiting fee when they we get a recruiting fee if they're successfully hired. So that was really great. But the thing we saw with that is that it was just sort of a fairly small market. We wanted to be able to help more students. So what we did was we said like, hey, look, it looks like there's a huge pent-up demand for this training that we have. What if we came in and said, hey, look, you can also pay for this, and that's called the Scholar Program. And it's sort of much more of a traditional educational model where the students are paying for the program. And then at the end, they can go work with whoever they want, work at whatever company they want. And so that's sort of how we started this. Obviously, it's this, and that's sort of the genesis of this, what I want to say. And obviously, this is the same program. You're sort of, the fellows and the scholars are sitting in the same room, working on the same materials. So there's no difference, right, in terms of what the education you receive or the sort of the grading standards or what have you. But it's really just an opportunity for us to figure out how do we expand this program so that we can touch more lives and help more people be able to get through that program. And we're still doing the fellowship, and we're still very committed to this idea that we want to help some folks be able to go through this for free. But we also have a scholars program that is paid as well.
Mm-hmm. Yeah, it seems like there's a choice for everybody, which I really love about the program. But now I want to talk about you. I mean, we got so many questions about you personally, Michael. Everyone is super interested in sort of in your background, and a lot of people asked, what are some of like the favorite projects that you worked on, right? Like some of your favorite data projects and why?
Yeah, there's just a lot of them. And I actually have I think I started a running list at some point of the data projects I want to do, but I never had time to do. But one of the ones I took off the list maybe a year ago, was really around kind of analyzing data and design. So looking at, so by design, I mean web design. Really like what do websites look like? And what do they, what kind of font do people use? How big is the font? Are they to use images? Is it predominantly text, right? Like all these kind of big questions. And you'll find that if you sort of like go into the web design world and sort of build some websites, and I've done that, there's no real data around that. It's very kind of, I guess, what you might call an artistically craft-minded discipline. And there's a lot of sort of conventional wisdom, which is great. But there isn't a lot of data that sort of says like, hey, this is where the industry standard is. And the funny thing is, of course, the web is like immensely crawlable, right? So it's actually very easy to get this data. So what I did is I went to, I forget what the source is, like the Majestic Million or something. There's some web source that's like, hey, here's the top million websites in the world. Just crawl all of them, pull them down, the HTML and the CSS, and then you can start like parsing through this stuff and looking at, well, what kind of fonts do people use? Do they use serif or sans serif? What's the difference between the way titles are written versus the way text is written? So I guess this might be like super inside baseball unless you care about design. I did this, and I sort of did a bunch of analysis on these top million websites, and I published it in a place called, I think it was Dribble. You can look this up. But it was just sort of like an analysis of what these different sites were. And it was really interesting how much engagement we got from the design community and people who were themselves practicing designers who were kind of interested in these questions. And they came to me the same thing. They said like, oh, I'm so glad that I actually know what's the benchmark size for font when I do a design, because then I at least know like, hey, am I larger than the average or smaller than the average? And it's not to say that any of this stuff is prescriptive, that you have to do what is average. But I think it's interesting to sort of know where you lie with respect to the benchmark. So then you know when you're doing something, what you're saying, right? And how you line up with what the quote-unquote average website looks like, or the median website looks like. So that's sort of been a fun kind of passion project of mine recently. And I think I have a list somewhere of like a bunch of them. So if you want to like, if someone is looking for ideas for what to do with the fellowship, you're more than welcome to sort of go rummage through that list of ideas. And I'm sure I have many more.
That's awesome. Well, keeping on kind of the tone of like the technical, right? What are some, we get a lot of this, right? Because we have a lot of TDI webinars and offerings where we are doing live demos. And we get this question all the time. Should I learn R or Python if I want to be a data scientist, and why or why not?
Yeah, I think from a kind of practical career perspective, I think there are people who are R people and there are people who are Python people, and both of them have kind of very successful careers doing data science, doing lots of great things. So I think it's sort of, one can do both. I'm personally a bit more of a Python person than an R person. That's not to say that there aren't sort of great things about the R ecosystem that I think don't exist in Python. So like dplyr is really amazing. It's a sort of it's the equivalent of pandas in R, right? And it's just sort of this like really great library that has this like much more intuitive syntax than pandas does. And yes, like I'll be the first to admit, like pandas is sort of just like this hodgepodge of stuff that's like very effective, but there's no rhyme or reason why these functions are named the way they are. Whereas like dplyr is clearly like a much better way of doing it. And you can't really put it over to Python for various technical reasons around the shortcomings of the language, so to speak. And that's just sort of a very beautiful thing that happens in R. But overall, my personal bias is towards Python because I think that it's nice to tap into a language that is used by a very, very large fraction of the programming world, right? And it's this ability to plug into the hundreds of ecosystems that weren't built for data science necessarily, but they were built because some web dev needed this tool, or that somebody who's running system administration using Python needed some tool. And having access to all those is what makes, to me, in my mind, the Python ecosystem that much more rich and that much more powerful. But then again, I have many colleagues and friends who are of the R persuasion and will sort of give you a convincing argument as to why R is preferable, and that's totally fine. I think in the end, you can do really well and have a great career in data science knowing one or the other.
Mm-hmm. And I really liked what you talked about earlier when you're talking about some of those passion projects that you were doing, and you were like, look, a lot of it's, digging in, looking at those benchmarks, right? Like, do you think that if someone wanted to get started in data science, that they would need to know these things? I mean, it seems like an intimidating thing. Could they attend a demo or two? Should they take an introductory course? What are your thoughts on that?
Yeah, I know we do a number of demos around as part of sort of our efforts to reach out to the community. And so there's lots of stuff that you can follow if you follow our Twitter, like @TheDataInc or the Pragmatic Institute. And I know we also sort of from time to time offer kind of like an intro course to help folks along. So I guess I would keep your eyes peeled and abreast of that.
Yeah. Absolutely. And I know we have those. I know Nikki's hard at work making those happen all the time. So I want to take a step back here, Michael. I know that, look, these data terms, right? They can be a little tricky. So if I could get you, can you explain the difference between a data scientist, a data engineer, a data analysis? Like, what are those biggest differentiators, do you think, between the roles?
Yeah, so that's a great question. It's a question I get a lot. And I think that that's often a source of confusion for a lot of folks in an industry. So maybe the easiest way to think about this, the easiest way to think about this is first talk about the data engineer, right? I think that data engineers are much more focused on the engineering aspects of the job, of the sort of data tasks that need to be done. So, at any large organization or any organization has a large amount of data, there's just a lot of plumbing that has to happen to make the data flow from point A to point B, to take it from a production database into an analytics database that you might need, to be able to set up your Spark cluster so that you can do your analysis easily. And that work doesn't come for free. It's a lot of engineering, right, to kind of move that around. But it's a specific kind of engineering. It's not engineering to build a website. It's not DevOps. It's really data engineering. It's the art of moving trillions of bytes of data around. And that's that's sort of the role of the data engineer. Now, if you move more towards the kind of analytical side of things, I think you encounter these other two personae, the data scientist and the data analyst. I think that, these lines are very blurry. And so it's hard to sort of say exactly where one stops and the next role begins. But I think in general, when people talk about data analysts, they're talking about people who are more focused on the business problem and the business side of things, and are perhaps not as sort of in the weeds of the technically sophisticated stuff like machine learning or deep learning, and are much more focused on the kind of business problem. And their tools of choice may be more things like SQL or basic pandas, right? But they're not tending to do sort of very heavy duty machine learning. And that's not to sort of poo-poo them or sort of be pejorative, and in fact, actually, I think those roles are very, very important, because in the end, a lot of important business questions come down to something simple like logistical regression or a SQL group by. So they play a very, very important role. But a lot of their output, if you will, is actually kind of in the form of influencing others. So it's helping business decision makers understand the data side and the evidence around the alternatives that those business decision makers face. And that kind of workflow is extremely important. And it's still very data intensive and can oftentimes be, using the same data sets that a data scientist might be using or that a data engineer has been building. So that's sort of the data analyst side. Now, on the data scientist side, I think you're sort of getting towards people who are more focused on the fancier tools of machine learning, if you will, who are using slightly more advanced tooling. They may be answering kind of questions that are driven by a business person, especially at a small company where they often have to play a role of both a data analyst and a data scientist. But when they're specializing much more in that kind of the more advanced tool set. And their deliverables are often not sort of a PowerPoint or a report that a human consumes, but a model that gets pushed into production, that's doing recommendations, that's might be doing ad targeting, right? These sort of more classic data science type outputs.
Yeah, I think that you just that's such a stellar example of like the types of patterns that each role will be looking at, the types of tools that they'll be using. So that is an A+ win. Thank you for that, Michael. I also want to ask a little bit about, obviously you had kind of dug into that a little bit, and I'm sure that there might be some bias here, but do you think that maybe there is one path better than the other? Would you maybe suggest something for a certain individual as opposed to the other? I mean, what are your thoughts on that?
Yeah, it's I think it really just comes down to what's your interest and where your interests lie, right? There are very successful careers in all three of those disciplines. And obviously we sort of support people who are looking to get into all three of those disciplines. So I think that's a very easy, there's lots of opportunities, and it's probably more comes down to an individual's own inclination or interests, that will sort of drive that kind of very personal career decision for them.
Absolutely. And I think, even just breaking that down, right, those examples of the patterns that you'll be looking at, the types of tools that you'll be using, I mean, those are all really, really helpful indicators of what space you might
Absolutely.
Terrific. So how about somebody, because again, I feel like data is this intimidating term, right? Even though we use it every day in all of hopefully the business decisions that we make. For somebody who maybe wants to get into data, right? They're a novice, they've never done it before. What would you suggest some ways for them to get their feet wet?
Oh, yeah, that's a good question. Yeah, and we see this all the time with people who want to who are data curious, who want to learn about what a career in data would be like. I think there's really, I have this great expression that data science is not a spectator sport. And I think that's very true. It's a participatory sport. So, you can go and watch all these Coursera videos about how you're supposed to do data science and how to do logistic regression or use TensorFlow. But in the end, unless you actually use these tools on real data, you're not really learning anything. And so I think the advice really to folks is to kind of get your hands dirty, start learning how to use a tool like Python or R to manipulate data. If you're not there, you feel like it's not quite ready for you, then at least use something like Excel to start playing with these tools and start playing with data. And I think that we carry that philosophy all the way through, right? It's not just something we say to applicants, but it's also something that we practice in our fellowship and in all of our corporate training courses. So it's about, sure, we'll do some lectures and we'll talk to you a little bit, but about the theory or how these libraries work. But in the end, the thing that really matters is actually just getting your hands on keyboard, working with real world data, dealing with the messiness, dealing with all of the myriad of things that can go wrong. And it's a very, it's its own skill. It's not just programming, but it's also not just purely kind of business intelligence. It's its own sort of skill and discipline. And I think that's what that's what folks will learn in our program. And that's what they should start sort of getting themselves familiar with even before they apply, because it's a big commitment, right? Of your career and your time. And so you really want to make sure that this is the thing that's right for you. So, roll up your sleeves and start working on it, because that's the only way you'll realize that this is the thing you want to do.
Yeah. And I think we can both agree. We love getting into the messiness. So want to ask you a quick question here. Obviously, I think that this is another big question that we get asked all the time, Michael, but, experience versus education, right? How do you kind of look at those, right? Is it more important? Does education outweigh that experience, or is experience really what companies are looking for these days?
Yeah, I think companies are looking for people who can get, who are skilled and can do the job. And, how we figure out whether or not people are skilled and can do the job is a complicated question. And sometimes that comes down to education, right? Oh, they went to the data incubator, they should be able to do this. Or it comes down to experience, right? Like, hey, they've been working as a data scientist for 5 years. And I think that it's, it really comes down to being able to demonstrate the skills and in an interview, whether, however it comes. And that's one of the reasons why we are so focused in our education around being hands-on keyboard and getting just sort of reps in, where you deal with dirty data sets, where you're dealing with the actual tools you would be using on the job. So one of the things we do for all of our scholars and our fellows is we spin up cloud instances of our training materials and embedded in a Python environment, so that you can start playing with those tools right away. You don't have to deal with some of the messiness that's involved in setting up a data science environment. And I think that's kind of is very helpful for just getting folks started, right? And I think that this is that sort of experience of dealing with data, whether it be through a program like the Data Incubator or through a program or through your own sort of self-directed learning or through experience in a job. I think that's actually what really matters.
Mm-hmm, mm-hmm. Great advice. And we got so many questions on that. I want to make sure we get to Samantha's. So again, right, that education versus experience conversation. Samantha DM'd us and asked, I got offered a job as a data scientist, but it's not my dream job. Should she hold out for something that they want or take this one to get her foot in the door?
Oh, that's an interesting question. I'm going to say, let's pause on that. Samantha, I'm curious to know why you think that's not your dream job. And then I think I can give you a better answer after you answer that. But I'd love to just hear why that's not. So maybe why don't we go to the next question, and then hopefully Samantha will provide an answer and we can come back and
answer. Yeah, absolutely. So another one that we keep getting is we keep hearing about a skills gap. But we're out here doing the work to close that skills gap with, the Data Incubator. Can you kind of explain what the skills gap in data science means?
Yeah, I think and data science is not the only place you see a skills gap, but maybe it's one of the places it's more acutely felt. Look, it's hard to find people who really are good programmers, right? Like, this is just, everyone who's in Silicon Valley knows this. Now, imagine if you had a job that requires that you find someone who's a good programmer and knows a bunch of math and stats. It's already hard to find people who know math and stats, right? We all know this. And now layer on top of that, especially if you're a data analyst, somebody who has that ability to do storytelling, who can sort of take a complex narrative and tell you like, oh yeah, there's lots and lots of regressions here. There's lots and lots of tables of data, but here is the story and here's the data that backs that up, and can kind of tell that compelling story, and pull out the sort of thesis from the noise. That's a really hard person to find. And I think that's sort of what we're seeing in the skills gap. So what we're trying to do is help create more people who are trained in the art of data science and the sort of skills of data science, so that they have more programming background, they have a stronger math background, and they have a stronger storytelling background.
Mm-hmm, mm-hmm. Yeah, and Samantha chimed in. She says she loved your example of the data engineering. And she says she thinks that I want to work closer to that side of the table, but I'm worried it will be harder to obtain. So she feels like there's more data science jobs than maybe data engineering jobs. Is that true?
Oh, interesting.
Yeah.
So it sounds like Samantha is saying that she really wants to be a data engineer. She has an offer as a data scientist and maybe is thinking, and I was trying to decide. I think that's sort of, it's a kind of a complicated answer, and obviously it's hard for me to sort of say, tell you one way or the other. I think a few things to keep in mind are like, what's your current job, right? If you are, I'm just going to make up an example, right? If you are currently a sales clerk and you want to get into data, then presumably moving towards data science is becoming a data scientist is a lot closer to becoming a data engineer than being a sales clerk. And it seems like that's, we can not always end up exactly where we want, but if we can move closer every day, then like eventually we'll get there, right? So I'm in that situation, I might say like, hey, just go for it. Now, if you don't like the culture of the company that you would be joining, if there are other downsides, maybe it doesn't make a lot of sense to join. Or if there's like another offer coming down the pipe that is for data engineering, then maybe it doesn't make sense to join. But if you are looking at this from hey, let's just become, I want to become a data scientist, and this is I want to become a data engineer, and this is getting me closer to that, you may be able to join. And then in an organization where there's multiple data scientists, you might find, especially if your own natural inclination is more towards data engineering, that it's easier to transition that role within a job maybe at first without taking a new title, right? But you end up doing more of the engineering things because you're interested, and the other people are more interested in the analysis or the model building, which is great. And you just kind of move your way towards the job you want, taking the projects you want. And then eventually it sort of becomes clear to everyone that you have a kind of different role, and you can define yourself as a ML engineer or a data engineer or whatever, whatever title you want. And that kind of is maybe a way of making that transition. Mm-hmm. Just an idea.
Yeah, no, I think that's great. And, I would love to just kind of hear, because there's so many of the skills that are transferable, right? It's like, getting this skill set and being able to understand, and then you can kind of utilize it in a way that you're most interested in. Can you kind of just list off a few skills, Michael, that you think, could transcend through all three of the careers?
I think there is just a kind of a basic understanding of, hey, how data works, what data is about, and really some ability to program, right? That's kind of very important for all these roles, because usually when you're dealing with, in the big data world, there's just so much data that's using point and click tools is not as effective. And also the ability to kind of do custom things, right? Programming languages are wonderful because they're infinitely flexible and you can do anything you can dream up. But when somebody gives you a point and click tool, well, you're sort of stuck doing the things that they allowed you to point and click. And so I think the flexibility of the programming language is sort of very key to that.
Yeah, and you've touched on it a few times, but it's curiosity, right? It's willing to dig in and kind of get in there and be a part of those live demos, like get into those articles and blogs and kind of do your own discovery.
Yeah, look, I think that we live in an era where, and not just with data science, but also certainly exemplifies this, we're going to be lifetime learners, right? We're always learning new things. I'm always learning new things, and I've been in this industry for a while. So we just have to sort of have that kind of growth mindset and focus on like, hey, what's the next tool out there that will make my job, make me able to do my job better, faster, give me capabilities I never had before. I think that's you're seeing that all the time.
Mm-hmm. Yeah, we just had, for Pragmatic, I know we just had the innovation in March, and so many interesting conversations came up with that, right? How do you think boldly? So I really appreciated that. This next one I have for you, Michael, is a two-parter. So number one, right? Data science. It's one of the two top jobs in the entire world, or one of the top jobs in the entire world, I should say. Number one, why do you think that is? And number two, is that a trend that you think will continue?
Oh, yeah. I mean, absolutely. People ask this all the time, like, hey, have we reached, I don't know, peak data science, so to speak, right? Or peak data. And I don't think that's the case. I think what you're seeing is the confluence of a number of events that are sort of broadly kind of driven by macroeconomics, right? The fact that computing costs have gone down exponentially, the fact that storage costs of data have gone down exponentially, and the fact that actually networking costs, this is sort of the subtle one, the ability to move data from point A to point B have gone down exponentially. All of this is actually what's driving the data revolution. Suddenly, it's actually now possible and worthwhile to store lots of data and then process, to transfer it, to transmit it and process it, and to be able to glean insights from this. I think people would have loved to have done this generations ago, but we just didn't have the compute capacity and the network capacity and the storage capacity to do this. But now that we have it, we're seeing this huge value creation from data. And that's not to say that the industry is going to stay the same way as it always has, right? I think privacy is becoming a bigger deal. We're seeing sort of data nationalization where countries are sort of saying like, hey, we want data sovereignty and all of our data should reside in our country and can't be hosted in another country. So we are seeing these things, but I think they're actually in many ways, one, it's healthy, right? We do want more privacy. We do want privacy protections. But two, it doesn't really reduce the amount of data science you can do. What it really means is that there will probably be a data science team for one geography and a data science team for another geography because of these regulatory hurdles. And so I sort of see this creating more opportunities for data scientists, data engineers, and data analysts going forward. And like, I don't see these trends changing anytime soon. This is sort of, deep and structural, and probably we're just at the beginning of this data revolution.
Yeah, no, absolutely. I mean, I definitely think that there's so much opportunity in it. And, I know just in my own education and taking the courses, I mean, it's just invaluable, really, what you can do with it. So I think that's fantastic. Well, I know that we are about to hit our time, so I wanted to see if there was like maybe anything else that you wanted to add, Michael, but we certainly appreciate getting to pick your brain and hear from the source. Absolutely.
Yeah, look, I think this is a really exciting time to get involved in data science, to start a career in data science. So if you're interested in doing it, just, you know where to apply. You can go to the dataincubator.com and sign up for the fellowship. And yeah, we hope to see you there.
Yeah, terrific. And thank you to everybody who sent in their AMA questions today. We got a ton. If we didn't get around to answer your question, I know that we did hit our time, but make sure to email us at admissions@thedataincubator.com. We will make sure that Michael sees those. Keep an eye out on our social channels as well. As we said, we always have those data demos. We're always doing future events, blog posts, and things that can keep you informed about those best data practices for you. So again, if you are interested in applying to our fellowship program, you can find us online at thedataincubator.com. With that being said, thank you to everyone for attending. Michael, thank you for your time, and we will see you again. Thanks,
All
gang.
right. Thanks, everyone.
Take care.